I was saying, I will repeat that again once for all of yours benefit largely, which is that Professor Shimon is a professor and founding dean of the School of Computer Science in IDC, Herzliya, and Israeli University. He also taught at Harvard, Stanford, and New York universities. He was chairman of the Computer Science Curriculum Committee of the Israeli Ministry of Education, and he's a co-founder of Matific, a global company with respect to the math education, whose award-winning mathematics games are used in 50 countries, 50 plus countries in fact, and Shimon presents the first ideas that led to the formation of Matific in 2012 in fact. Our topic is very contemporary, I would say, with respect to how will the mobile devices transform the early age, I would say, education with a subset of maths education largely. So we love to hear from Professor Shimon in detail for that matter, how will this and his learnings will possibly help back here in India for that matter. We will divide, as I said, this session into two halves. The first half, Professor Shimon will take us through his learnings, his understanding of the given topic which we have in our hand. And obviously after, in our second half, we largely dive into the Q&A part of the entire discussion, because I want that our questions should come through in the most relevant fashion. At the same time, if you look at it, we have the chat window enabled for that matter, but I would request all members who are joining in, so please keep the chat window for the relevant conversation only. If you have an observation to make, please make a mention on the chat largely. There is no point sending your introduction or sending a good morning or a good evening there largely. It just clutters the entire conversation. Good to have you all. As I said, we will start at sharp 5 o'clock, which is 5 minutes away from now largely. Obviously, I was getting a lot of interest on the group with respect to a sort of a national education policy document, which has come yesterday. And obviously, every one of us largely are putting our hands around it largely as to what it is. So we will be hosting a session soon on that as well. Largely, we're trying to pull in good experts who can really demystify that for us as a session. A very important policy document after 34 years in India, so which we for sure would love to make understandable at your level. We will try our best to do that for you. But for today, I think Professor Shimon is joining us from Israel largely. So Professor is based out in Israel, and he is with us. And while I was having a conversation, he's been to India as well, and he was in Jaipur for that matter. He very well knows Jaipur is in Rajasthan, so fairly good understanding, if I may say, he has about an Indian perspective. So having said this, Professor, good to have you with us, number one, and I will somehow be far more comfortable in saying you Professor than Shimon. Somehow that's in my DNA, but I'll try my best to say Shimon as well. Good to have you with us, sir. And I think we are 4 minutes away, and we'll start at sharp 4 o'clock.
Yeah, we'll wait.
Yeah. So there is an interesting, I will quickly share with you an interesting observation which has happened. In fact, that's something which caught my attention on the National Education Policy document in India yesterday, which is that coding has become, in a way, a very integral part of the schooling. After 6th grade, I'm not sure of, I will ask one of my leaders, Deepak, is it mandatory or it is optional as a thing, coding?
Good evening. Sorry, Gaurav bhai, I was doing something, so I missed that question.
Okay, I was asking that the coding bit is the coding which has been mentioned in our NEP. I was listening to the Honorable Secretary, in fact, Mrs. Karwal ma'am yesterday when she was making an announcement. Is coding mandatory after 6th standard or it is an optional thing?
Yes, it will be mandatory.
Okay. So Professor,
and the things will be clear by at least 24 hours.
At least yes, it will take almost 24 hours.
At least 1 or 2 documents must be released in which they are shorten out their words and they have to release their supporting document. Okay. Let them come first, then we will discuss it and we will going to have a session. So we will discuss all the points.
Fantastic. Okay. Very well done. So, but I am assuming that coding is an integral part of now the curriculum. Is for that matter, right? Fair. Good. And anything else which you thought was of important relevance you could think of? Because right now you are the only person on video who I can see. Jyoti Samantha also I can see. Ms. Jyoti, have you been able to go through the document by any chance? Because whatever tertiary level information we have right now, we don't have complete information, but we certainly have some snippets of information available with us largely.
Yes, sir. There are a lot of good changes, but I hope everything is taken care of. Only I was more worried about what will be the promotion system, whether we will have any rigid promotion system, or is it going to be, like what we had till last year, till 8th standard, we had all promotion. So is it going to be like this, or is there going to be any, a solid promotion system to be conducted before you carry the child to the next class?
Okay.
So I would want I want clarification for that. I'm looking forward for something nice.
Okay. So we'll keep this discussion for. I'm planning something very, very soon. In fact, rather. So I'll announce that by evening today itself about that discussion of ours, which we will have. But having said this, over to Professor Shimon. I think I had to stop your screen sharing that time. So if you would like to please go ahead, sir, and you can screen share the document, and over to you largely. Yeah.
Okay, so you see my screen now?
Not yet.
Not yet, okay. Let me reshare it. Hold on.
Yeah. Now this is fine.
Yeah. Okay, you can see my screen. It's a black screen. Okay, fine.
Right.
All right. So shall I start?
Yes, sir. Absolutely. Please go.
Okay.
I did make your introduction while you were not around.
Okay, thank you. So once again, my name is Shimon Shoken, and I'm really excited to be in this meeting today with so many education leaders in India. I guess that in this talk, I represent a company called Matific, but I also represent myself. I'm a professor of computer science who teaches both in United States and in Israel. And about 8 years ago, myself and a group of other colleagues from several countries have started up this company called Matific, whose goal was to try to make a revolution in the way we teach mathematics worldwide. And I'm very pleased to say that since then, the company became truly international. The headquarters of the company is now in Australia, but we have offices, I think, in something like 10 different countries, including, of course, India. It's a fairly large company, compared to what we do. We focus only on mathematics education, and we have about 100 employees. And although it's obviously a for-profit company, many of us work in this company for the sheer love of teaching and pedagogy, mathematics, computer science. These are things which are very close to our heart. And our main goal is to simply improve education as much as we can in disciplines which are close to our hearts. So I spend a lot of time working with children and developing educational materials to teach mostly mathematics in elementary schools. But I also spend a lot of time teaching in universities. And you see me here with my students at IDC Herzliya, which is an Israeli university that I helped establish about 25 years ago. And in particular, I built the School of Computer Science in this university. And I'd like to start the talk with a little bit of bragging, and I will ask a question which I will then go on and answer myself. And the question is, what is common about all these companies that you see here? So typically when a computer science professor shows such a set of logos, the answer is that every one of these companies employs some of our graduates as team leaders and so on. Well, in my case, every one of these companies has acquired a company that was started up by one of my students. And some of them acquired, several such companies, like Google and Microsoft acquired actually 2 and 3 companies that were started up by students that graduated from my school. And I'm saying this because I think that even though the students are very gifted and capable on their own right, apparently we also do something right in the way we teach them computer science and mathematics. And I would like to share this teaching philosophy with you today. This is the main goal of the meeting for me. It's less of a meeting about how to use Matific. This is something that other people can do better than me. It's more a meeting about the Matific spirit or the ideology behind this company. And this spirit is consistent in the way I teach both mathematics and computer science and everything else. And that's what I want to share with you. So let me start by, saying a little bit about some online courses that I teach, which have little to do with Matific. This is what I do in academia. So I teach 2 courses in Coursera, which became extremely popular recently in the last 2 or 3 years. So in one of these courses, I have now 100,000 students enrolled, about a third, and about 30,000 students in the second course. And the ratings of these courses are quite phenomenal. As you can see, it's 4.9 out of 5 in one and 5.0 out of 5 in the other. And since these courses became very popular, I'm being invited to give talks about how to create a great online course. That's a question that people ask me. They want me to share the formula with them. And obviously, there are all sorts of success factors like pedagogy. When I say pedagogy, I mean the quality of the lectures and the quality of the homework assignments and the projects and so on. That's for me is pedagogy. But in addition to this, there are all sorts of other issues which are very important for online education, like modularity and granularity, the ability to take complex subjects and break them into small pieces that students can consume, if you will, online in something like 5 minutes, 10 minutes, because more than this, they sometimes lose span of attention. They have a very limited span of attention for learning from a cell phone screen or from a tablet. So you have to be able to teach in a very modular fashion. You have to be able to give ongoing feedback about what the student is doing and motivate the student. The education should better be personal, so that different students get different treatments based on their revealed competence, which is something that you can diagnose as you teach online. And of course, you have to engage them. If you cannot engage the student will simply walk away. But when I think about all these success factors, the most important factor is simply pedagogy. This is an absolutely required condition for a successful online course. it beats everything else. You know, everything else is important, but if you don't have pedagogy, you have nothing. And so in many cases, when people ask me this question, how to build a great online course, my answer is very simple. Build a great course and put it online. And I'm saying this because, you know, when I look at the most successful MOOCs in Coursera, I know many of the instructors of these courses, and these are courses that were extremely successful when they were taught in, you know, at Stanford and MIT and IIT Delhi and so on. Great courses. You know, when you put them online, they remain great. And what happens is that exposure blows up. So instead of teaching 100 students each year, you all of a sudden teach 100,000 students. So once again, this, you know, goes back to my argument that pedagogy is the most important element. And this is a very kind of old school argument. You know, I'm not talking about technology. I'm not talking about artificial intelligence. I'm just saying you need great teachers preparing great educational materials. That's the secret for online education, offline education, and education in general. Now, you know, I think all of us are very interested in this question. You know, what will change in the next 12 months in this crazy period that we live in? And, you know, when I think about this question, I cannot not think about Mark Twain, who said that you know, it's very difficult to make predictions, especially when you deal with the future. And so I cannot answer this question. And you know, maybe I can try to answer another question. You know, what will change in the next 12 years when it comes to education? Well, I cannot answer this question either. But I think that I can answer this question. What will not change? What will not change in places like India and Israel and Australia and the United States is that 12 years from now, we're going to need plenty of engineers and scientists and developers and entrepreneurs. This is obvious. And the common denominator of all these professions is solid mathematics education and feeling, you know, confidence with quantitative reasoning and with rational thinking. That's what, you know, mathematics education is all about. And therefore, I think that it makes a lot of sense to spend, you know, a great deal of resources and attention on mathematics, because it's one of the only subjects that I can think of that encompasses so many other disciplines in them. Yeah. And also, you know, not to mention the fact that, you know, many students develop a resentment to mathematics early on in their education, and this resentment prevents them from later on expanding their education into physics, chemistry, computer science, and so on. So instead of being something that students will enjoy and celebrate, it becomes something that they dread. And so many excellent students, you know, go on to study things like business and, you know, some accounting and other subjects, which are important, but it's a shame because these students, these accountants and business people could also become great scientists and engineers if only they were taught mathematics in an engaging and effective way when they were young children. So that's what we're trying to fix with Matific. So here's a picture of a typical classroom in some Western country, in some European country, and the teacher is teaching fraction division, and she's asking a question. As you see, lots of students are raising their hands, and apparently many students know the answer because, you know, the way fraction division is being taught in many schools is, how does the saying goes? It goes like this, don't ask why, just invert and multiply, okay? Well, if that's a lesson, the answer is easy, and many students raise their hands. And yet, at least in Western countries, only maybe 2 students out of 30 or 40 students in a class will become scientists and engineers and physicians. And the thing that distinguishes these students from other students is that they understand most or the majority of what is going on in these math lectures, whereas all the other students are swimming. All the other students get stuck at some point in the mathematics education. For example, when they study fractions, many students don't understand what is the meaning of common denominator. They know how to compute common denominator, but they don't understand why they are doing it. And so they develop something which is really scary. They develop an ability to answer questions correctly, but they have no idea why the answer is correct. And this is a very uncomfortable feeling, psychologically speaking. And so they begin to develop gaps in their understanding of mathematics, and the class, moves on, and they are still stuck with not understanding something that they learned 6 months ago. Not to mention the fact that many teachers don't fully understand what they teach when they teach mathematics. And I cannot blame them because, most teachers are not trained to teach mathematics. They are trained maybe in another discipline, or they are trained to teach many different subjects. And so teachers are also uncomfortable about mathematics. And that's another thing that we want to try to change. And so we run into a situation in which many students and teachers dread mathematics. And let me give you an example. We talked about fractions, and now let's look at geometry. Now, in many schools, many classes, students are being taught that the triangle area is base times height divided by 2. All right. And then they get, all sorts of questions, specific triangles, in which they have to compute the areas of these triangles and so on. And unfortunately, this is not mathematics. This is robotics. Giving a formula and asking a student to fill in some numbers and multiply and divide by 2 is something that a robot can do much better than a child. So obviously it's important to ask such questions. And the question that you see on the screen here is important, provided that the student has already understood the conceptual meaning of what he's doing. But if the emphasis in the class is on such questions, on techniques, on procedures, we're going to lose the students. The students will become bored and resentful because they will not understand the meaning of what they're doing. And so it is unfortunate that, that in many schools, the emphasis is on technique and procedure. So how can we do things differently? How can we teach triangle area in an enlightened way? Well, let me try to show you. So, I'm looking at this shape here, which I can draw on the board, and I can do it easier with the computer. And, maybe I can start moving this blue shape around. And as I move it and show it to the student, I can begin to ask them at some point, what do you think is the area of the blue shape? Well, maybe we can draw this line here to help us think about this question. And you know what? Let's focus on the left side of the shape. I think that you will agree with me that the blue and the yellow have exactly the same area. Now, let's take a look at the other part of the shape. Isn't it exactly the same argument? I mean, don't we have here also exactly the same 2 areas? I think you would agree that the answer is yes. Well, if you put these 2 things together, you can reason that the area of the blue is exactly 1/2 of the area of the rectangle, of the area of the box. And it doesn't matter where this where this triangle is located. It's the same rule everywhere. Everywhere you look in this setting here, the area of the blue is exactly 1/2 of the area of the rectangle. And it becomes dramatically so when you go all the way to the left, right? When you go to, you literally see that it's 1/2 of the rectangle. And so, you know, you just discovered yourself that the triangle area is base times height divided by 2. And once again, it doesn't matter, you know, where this triangle is located. Now, what we saw here is an example of hands-on learning. You know, learning by doing, learning by experimenting, and not learning by being told that here's a formula, apply it. Okay, and more than that, you know, what the student has learned is something which is very profound. And let me try to highlight, you know, the profound part of it. You know, the fact that the area is base times height divided by 2 is interesting, it's appealing, but it's not the most important thing that the student learned. The most important thing that the student learned is that this formula applies to all the triangles in the world. You know, it doesn't matter if the triangle is on planet Earth or in the moon or on Mars or whatever, or in my head. As we saw in this example, you know, there are infinite number of triangles in this box, and all of them have exactly the same area, which is base times height divided by 2. So what the student discovered here is a law of nature. And I think that, you know, as teachers, we have an obligation to be excited about it and to convince the students that they discovered something which is very profound. And that's, you know, that's the beauty of studying mathematics and science, that every once in a while you discover something which is greater than yourself, right? A law of nature, something which is greater than yourself. And if you do it with your own hands, you know, you feel like the first person who discovered it. And it's extremely empowering. So that's the sense that we're trying to convey when we teach mathematics. So in Matific, we view mathematics as something that combines playful exploration and experimentation and hands-on discovery. Now, the role of the teacher, and in some cases, the role of Matific, is terribly important here, because, you know, think about it. First of all, I have to come up with this example. I have to come up with this little experiment. And then I have to push the students into a position in which they begin to play with this triangle and move it around. And then I have to suggest that, you know, maybe we'll draw this line. And from this point on, I should, you know, tease out. I should try to encourage the students to discover for themselves, you know, the relationship between these areas. And some students, the better students will do it. And the less than the better students will need some help. So I will have to, you know, to be more proactive and give some hints. And so the teacher, you know, should not be this, you know, in America, there's the saying, you shouldn't be the sage on the stage, but rather you should be the guide on the side. You know, that's a great teacher should guide the student to learn on his or her own. So in Matific, what we do is we develop numerous games like, you know, like what we saw here, and we gamify it. We make it more engaging, more interesting than just what we saw here. And we just stand on the side and let students play with these games. And when the students get stuck for some reason, or if they go in some unproductive direction, we give them a gentle tip, moving them into a direction in which they will see the light. And we work with teachers to learn how to use these games in the most effective and the most enlightening way. And I will have many demonstrations coming up. Now, there are different ways to teach these things. And, if we go back to arithmetic, then, the old school approach is to give worksheets like these, which students dread. And once again, I want to emphasize it's important to be able to solve such worksheets because it develops competence. It's important to learn by heart that 5 + 7 = 12. Because once you learn by heart your addition table and your multiplication table, then you free your brain to think about more important issues, right? You don't want students to begin calculating, what is 5 + 7. So it's very important to also give them interactive worksheets. However, it's important to do it only after the student understood in the marrow of their bones what they're doing, not before. And unfortunately, many companies that compete with us are stuck with this mode of learning. And in many companies, they say, let's bring in educational technology, and the educational technology looks like this, right? They take the same worksheets and they put some nice colors and icons and whatnot, and sugarcoat it, but it's exactly the same thing as we had, without computers. And in fact, there's a company that competes with us in Australia, for example, that has, I think, more than 1,000 schools using the software. And that's what they do. They put students in competitions in which they try to solve such worksheets, competing for time. And if one student did it, faster than another, he or she gets rewarded, which is crazy because, as I said before, robots will do it better, right? Better than students. So why waste time on such things? Well, it's because, it makes the life of the software developers much easier because it's very easy to develop such educational, if you can call it educational materials, right? So, if this laptop, if the camera of this laptop could take a picture of the student who is using this software, the picture would look like, it will look like this, okay? You cannot cheat children. Children understand exactly the quality of the material which is presented to them, and they're going to resent it. So what do we do in Matific? Well, let me give you some examples. When we teach geometry and we want to teach the notion of a trapezoid, what we do is we give the students a little lab, and we tell the student, make 2 trapezoids in this example. And there's a very important hint, use all shapes, use all 3 shapes. And we give them some tools. Sometimes we give them scissors, sometimes we give them scissors and glue, depending on the problem. And here, you try all sorts of things, and you discover at some point that if you will cut this rectangle and glue the other triangles, you're going to get 2 trapezoids. But you're going to learn it by doing, not by being told. So if you click the word trapezoids in this game, Matific will show you a picture of several trapezoids as examples. And then it will ask you again, now you see that's what a trapezoid is all about, now go build some on your own. And there's it's a different level of learning to build something rather than to being told what it is. That's one example. Here's an example that we teach in kindergarten or in 1st grade, in which we begin to discuss the notion of odd and even. And we found out that this property, which is very important in mathematics, is very easy to teach young children. And basically, we bring in flocks of birds in different formations, and we ask, do we have an even number or an odd number? And the way to figure it out is to, and if you don't see it, we tease it out from you using hints. The way to figure it out is to try to pair the birds. If you manage to pair all of them and no bird is left out from the pairing, it's an even number of birds. Otherwise, if one bird is left out, it's odd, okay? So you learn the notion of even and odd by pairing, and that's very important. You know, this is sometimes called seeding ahead, because we are beginning to teach the notion of division, which is always complicated in elementary school. Division is perhaps the most cognitively demanding operation, and we do it in first grade. So later on, in second grade, third grade, fourth grade, when we get to teach division, we can go back to the birds and say, you know what we did with the birds? Actually, we divided by 2. We tried to divide by 2. You know, some numbers are divisible by 2, and other numbers are not. And in all Matific games, there are always all sorts of suggested follow-up questions and activities that we give the teachers. So for example, here's a good follow-up question here. When you try to pair up the birds, is it possible that more than one bird will be left out from the pairing? And the answer is no, because if 2 pairs will be left out, if 2 birds, we're going to pair them up. So none will be left out. And if 3 birds will be left out, we'll pair 2 of them and 1 will be left out. So all of a sudden, you learn an interesting mathematical operation or mathematical observation. And the next thing that I'm going to ask you, and I'm going to show you, and you know, I don't have it, I didn't prepare the demo, but after you play with 1 flock of birds, 2 flocks of birds come in, and they are arranged in sort of a V-shape formation. And then we ask you, you know, is the total number of birds odd or even? And you will discover, you know, that you can take the 2 leading birds and pair them up, and then all of a sudden it's even. So you just discovered that the sum of 2 odd numbers is even, which is a profound observation. And you can figure it out in first grade. So once again, you discovered a law of nature, okay? And so very deep concepts, you know, that lead to understanding the whole notion of, you know, I don't want to get into advanced mathematics, but there's a whole issue of, you know, modular arithmetic, understanding the importance of, you know, the idea of the remainder from a division. You know, you can teach them using games like these. Now in Matific, we never have a single game. We typically have a suite of games. So this game will come with something like 10 different variations and levels of difficulty. All right, moving along, you know, here's an activity in which we teach the notion of fractions. And we teach the notion of fractions by dividing pizza pies and topping them. So here, the task may be something like, you know, cover 1/4 of the pizza with broccoli. And again, you have to do it hands-on. You have to do it yourself. And this will lead to, you know, more advanced exercises in which we begin to think about comparing fractions and adding fractions and dividing fractions at some point. And we always do it by hands-on exploration, always. But once again, you have to understand that every one of these subjects, you know, if you think about something like fraction division, we have, I think, more than 30 games, 3-0 games that teach fraction division in many different ways, in many different formats and settings. So here's another important issue in Matific. We always use and teach mathematics in a real world setting. You know, we don't think that we have to invent all sorts of fantastic scenarios and fancy artifacts. There's no need for that. There's a lot of mathematics going on when you divide pizza pies and pies and cakes in general. There's a lot of mathematics going on when you go to the supermarket with your parents. You know, there's a lot of mathematics going on when your father parks his car and takes a risk of getting a ticket, right? You can compute, you can try to compute, you know, what is the likelihood of getting a ticket in different places in where you live and so on. So mathematics is prevalent all over the child world. And that's what we focus on. We focus on realistic scenarios. So, you know, here's another example in which we want to teach the notion of chance and probability. And so we show, you know, a little story unfolds here, and you accompany this little girl in her walk in the woods. And there's all sorts of questions here. Like, for example, the girl is standing in a fork in the road, and the question is, will I see blue flowers if I take road number 2? Well, you look at the picture, and you know there are no blue flowers in road number 2. So the answer, I guess, is no way. But you see, the butterfly, which you don't see here, the butterfly flies every once in a while from one road to another. So if the question later on is, will I see the butterfly? Well, the answer should be maybe, right? Maybe. Maybe I will, maybe I won't. And if the butterfly hovers mostly around road 1 and only rarely in road 2, then you learn something about, once again, probability, you know, more than 50%, less than 50%, and so on. So you start with very basic concepts, and very soon, you know, you get into more complex ones. And that's another important thing about Matific, is that when you are in first grade, you see simple versions of games. When you get to second and third grade, you will see the same game with more sophisticated questions, with more challenging questions. And when you move to later grades, you will see similar games, but also with different animations and different styles, because, you know, children in first grade respond differently to style than children in sixth grade. In sixth grade, they want to see more robots, they want to see more animation, and in first grade, it's more kind of fluid and dreamlike and so on. So, you know, we're very sensitive to these issues also. Here's an example in which we teach several things. You know, first of all, we teach the notion of, you know, I guess a histogram. You know, we show a bunch of characters that each one of them has a collection of hats, you know, and at some point we ask an interesting question. We ask, what is the average number of hats that these characters have? Okay. Now, one way to teach average is a very technical way, and say average, well, simple. You know, add up all the numbers and divide by the number of players here, and you get the average number. Well, that's nice and good, but he didn't really understand what is the meaning of average. So in this game, we encourage the students to find the average by moving hats around and trying to distribute the hats among the characters evenly, so that every character will have the same number of hats. And we make sure that the number of hats will facilitate this solution, okay, of average. This is the first, you know, the first question that we ask with average, don't have a decimal point. And so the student learns, you know, the relationship between average and equal number of objects and division, which is, you know, paramount in understanding what average is all about. And so once again, when you teach a concept in mathematics, you have to strive to teach it from multiple dimensions and multiple channels, because different children respond differently to different messages. And the more messages you use, chances are that at some point you will find a way to the student's heart and brain, and they will understand what you're trying to teach. Now, here's a game in which we sort out polygons and learn about geometric figures. Here's a game in which we learn how to apply some basic mathematical reasoning. So, for example, in this game, the family goes out to walk in a zoo or out, in the sticks somewhere, and there are all sorts of fact sheets about various animals and insects. So, for example, this fact sheet says that a mosquito lives about 10 days, and the question is, how many hours does a mosquito typically live? So, there's nothing special or sophisticated about this game, but once again, we think in Matific that everything that you do in mathematics should be anchored in some realistic setting. So the child can relate, can understand that the question that he or she is being asked is not out of context. There's always an interesting context. And also there's this family which is walking around, which creates a familiarity and the sense of connection to the scene. So all these things are terribly important. Here's a game in which we teach counting and or what is known as step counting. So here we want to train students in step counting by 3. So they start with a number like 10, and then they have to go 13, 16, 19, and so on. But instead of writing it down on a piece of paper, we put them, in this avatar, plays the game, and now the avatar is located on 15, and the avatar has to choose to which station he wants to jump next. So that's a game that children really enjoy because we can speed it up. The more competent they become, the more difficult the game becomes. And once again, you have to understand, I'm not suggesting that technique is not important. This game builds technique. It trains the child to think automatically about sequences like 10, 13, 16, 19, and so on. Terribly important, but it's not the most important thing. The most important thing is to understand. But in addition to understanding, Matific also provides practice. And we have many such games, board games. Yeah, I suggest that one of our co-hosts will mute every.
Give me a moment, Shimon. Yeah, you can unmute yourself.
Right.
Yeah, good to go.
Okay. I do a lot of, I did a lot of teaching in the last 6 months on Zoom, and I found out that the most important button is mute all. All right, so here's another game. This game, this is a screenshot of a much more engaging game, and the birds are flying around, and it's very difficult to count them simply by putting your fingers on it. And we ask the students, how many birds do you see? And what we expect them to do is to drag the birds into the holes in the bird houses. And you learn very quickly that the best algorithm for counting birds is to, first of all, fill in one of these bird houses with 10 birds, and then count how many birds are in the other bird house. So if you have 3 remaining in the other bird house, you immediately know that you have 13. If you have 6, you have 16. That's a game that teaches the importance of the decimal system. And it teaches the difference between 110 and several units, okay? And once again, we have numerous such games with birds, with boats, with cars, with marbles, in which we teach the decimal system, in which we teach students, what is the meaning of a number like 307. You have to teach it in once again, a hands-on fashion. You have to have the child build the notion of hundreds. You have to have the child build tens and units and put them together. And we do it by, once again, hands-on playing. Here's another little game that we teach in either in kindergarten or in first grade. And the question here is very basic. Do we have more bees or flowers? But we don't want you to count. In fact, you cannot count because the bees are flying around like crazy. It's impossible to put your finger on it, impossible to count them. And the only way to figure out this question, and you discover it by yourself, is to take the bees and put them on the flowers. When you put a bee on a flower, it hovers, on the flower and stays there. And then after you pair the bees with the flowers, you just look at the picture. If there are more bees, if there are bees remaining without flowers, you know that there are more bees than flowers. If there are flowers remaining without bees, you know that there are more flowers than bees. Now, why is this important? It's important because we just taught them the notion of a bijective mapping, it's a very important and basic notion in mathematics. To map the objects in one set on the objects in another set. And we just showed them that to answer questions like, which set has more elements, this question can be answered without counting, which is kind of cool. It can be answered by pairing. So this is a very sophisticated strategy, answering one question by using a different strategy that seems to have nothing to do with the question, but still it works very nicely. Okay, so this is seeding ahead to begin to learn the notion of a function, something that you learn only in high school. A function is a mapping, between x and y, right? And if you begin to be exposed to that in first grade, you will become a sophisticated mathematics student when the time comes. And so, we have thousands of such games. That's what we do in Matific. We develop games that teach mathematics in the way of playful interaction. And I can spend hours talking about every one of these games because I have to tell you, we spend many days creating every one of these games. Let me say a few words about how we work in Matific. Basically, it all starts with a team of mathematics professors and mathematics teachers, and sometimes simply teachers who are not necessarily mathematicians, but they know a lot about teaching. And we sit together and we take a subject, like let's say prime numbers or negative numbers, and we begin to pop up ideas. How can we teach, the notion of negative numbers? And then at some point, someone will say, I have an idea. Maybe we'll create a game in which there is a high-rise hotel that has 30 floors above ground, and it has 10 floors underground. And we'll have a little guy running around from one floor to another doing room service or something like this. And we'll put him, let's say, we'll put the guy in -3 and give him an instruction to deliver this tray of food to the 10th floor. And we'll ask the child, how many floors do we have to go from -3 to +10? And then we'll play it. We'll play the game. Okay. So we come up with this concept, and then we build a storyboard around it. which takes several hours, of work to do the storyboard. And then we discuss the storyboard and we look for all sorts of bugs in the storyboard and possible improvements. And then finally, after the storyboard has been approved, we have a team of programmers from one side and a team of artists from the other side who begin to work on this problem. And so it takes sometimes, a whole week to develop just, one game like this one. But in Matific, we developed thousands of such games, so we already have a very good inventory that we can build, more things on top of what we did before. And that's one secret to our success, that we accumulated so many good educational assets. I think this is my last example, and I will soon open up for questions and answers. And in this example, we have to mix colors, and the task is fill the container with 69 liters of leaf green. And on the left, I hope that you can see it, there's a little legend that says leaf green can be made from 1/3 of blue and 2/3 of yellow. Okay, so the child can now begin clicking yellow and blue enough times to create 69 liters of green. We're 1/3 of blue, so I need 23 clicks of blue, and 2/3 of yellow, so I need 46 clicks of yellow. And once again, they understand the notion of, in this case, it's mixing, but it's a little algebraic expression, right? And they learn it by doing, by applying themselves to the given problem. So to sum up, Matific is first and foremost about conceptual understanding. We want children to understand deeply what they're doing. And the only way to learn what you're doing is by working on numerous hands-on concrete examples. There's a famous saying which is attributed to Confucius, like many other sayings, and it goes like, what I hear, I forget. What I see, I remember. What I do, I understand. And Matific is all about doing. The doing is self-paced. There's no time pressure. When a student works on a problem, some students will solve it in 5 minutes, and others, may require 15 minutes. If you do it in a classroom, it sounds like it may be a problem, but not necessarily so, because if you answer a question quickly, Matific will immediately give you another question. Okay, so you never get left high and dry. But that's one advantage, a tremendous advantage of online learning using mobile devices, that different students can advance in their own pace. They are not under pressure of a whole classroom, that moved ahead and they were left behind. Not at all. They can do it on their own pace. And finally, the only way to make it happen is to once again engage the students in self-discovery. And here I want to quote another great thinker, Jean Piaget, who was a psychologist, but also an expert in mathematics education. And he said, whenever we teach children something, we deprive from them the pleasure of discovering it on their own. Okay, and that's what that's what we try to do in Matific. We want to try to have the students discover everything on their own. Now, I thought that my talk ends here, but I just recalled that I have another little segment that I want to go through. And if you want me to stop at some point, just let me know.
Please take your time. Yeah, please.
Okay, so I'll go ahead a little bit more, and then in about 10 minutes, I will open up. So, we talked about addition. earlier. I want to show you how we teach addition in Matific. We start sometimes in kindergarten, sometimes in first grade, and we give the child this little game in which we ask them to create a necklace using 5 beads. So one simple solution is to simply drag 5 beads out of one of these plates here or bowls and create a necklace. And then you get something like this, okay? And then I can tell the child, why don't you try to create another necklace with another combination of 5 beads? And at some point, the child will come up with something like this, okay? And at this point, right here, you can tease out the following thought, okay? Not only we built a necklace of 5 beads, we begin to understand that 2 + 3 = 5. But you understand it in a very vivid, in a very visual way, okay? And then we will tease out another solution. Give me another necklace of 5 beads. Well, by the way, we also learn commutativity. We look at this string, we see right away that 2 + 3 is the same as 3 + 2. I'm not sure that we even have to say it explicitly. We just have to hint about it. If you teach it in first grade or in kindergarten, later on, you'll be able to go back to this game and pour in more meaning, more depth into it. So now here's another example. What do we learn here? We learn that 1 + 4 = 5, but we also learn that 2 + 1 + 2 also = 5. All right. Now, all these insights come because when we designed this game, we had the good thought of providing 2 bowls of beads and not 1. So the game is about creating necklaces of so many beads, but without feeling it, all of a sudden, you begin to understand addition. And we never taught you addition. We never said anything explicit. We never drew anything on the whiteboard. You discover addition on yourself, which is terribly important. You even learn that 5 + 0 = 5. Of course, if there's a teacher there or a parent that will help you to see this insight. I will ask you, how many beads do you take from the left bowl? And the child will say 5. How many beads do you take from the right one? And child, I didn't take any. I say, well, see, that's the meaning of 0. We just learned that 5 + 0 = 5. But 0 is an interesting number. When you add it up, nothing changes. Okay? But you learned it from doing. And so another important issue, which we love in Matific, is that almost every question that we ask has many correct answers. And by having different children come up with different correct answers, and by comparing them, the children get tremendous insights. They learn that they can solve the same problem in different ways. All these different ways are equivalent, and all these different ways lead you to understand different properties of addition, like commutativity, like associativity, and so on, like adding 0. So this is another, and the last quote that I'm going to use. Any subject can be taught effectively in some intellectually honest form and pleasing form to any child at any stage of development. I truly believe that this is absolutely true from my experience. And I'm saying this because I think that there are teachers and there are software companies that try to sugarcoat mathematics. and to add all sorts of embellishments to make it more palatable to children. There's no need to do it. No need. You can teach very profound and deep ideas in exactly the same style and the same language that you use when you deal with the most advanced subjects in any science. You can do it in first grade. And I think that's what an honest and excellent teacher should do, right? We don't want to teach down. We want to teach students as if they are intellectually equivalent to us, at least potentially, and we have to help them develop this potential. So these are sort of the 5 principles that we elucidated when we try to think about the principles that stand behind our Matific games. Every one of these principles, by the way, breaks down to about 10 sub-principles. And I'm saying this because I think that we may give another talk in IPN about a more detailed talk about the Matific pedagogy. And therefore, it's quite likely that you will see this slide in this subsequent talk as well. And so, going back to the subject matter. Now, this is what we did in 2019, only a few months ago, right? Less than a year ago. That's how we taught. And I like this picture very much, because what we see here is a teacher that uses Matific in a very clever way. If you zoom in, you see that what the teacher is doing, she's playing a game in front of the class, a Matific game. And she has only one computer in the classroom and a projector, and she invites volunteers to play with the game, and she discusses what is going on with the children, and she uses all sorts of follow-up questions that we give the teachers in Matific. And I also like the body language in this picture here. First of all, I like the fact that the student is sitting and the teacher is standing. This shows a lot of respect to the student. It could have been the other way around. I like how the student looks up to the teacher. And I like how the teacher stands. The teacher, just by the way she stands, it looks like she's very comfortable. She's very confident in what she's doing. So that's what we did in 2019. Fast forward to today, that's how students learn today, right? Whether we like it or not. They learn at home with their parents. And our job as teachers is to come up with great home activities. And at some point, we'd like to, hopefully we'll bring these activities back to school. But still, in Matific, we view learning as a total experience. And we expect students to learn mathematics not only in school, and I'm talking now in sort of pre-corona state, in a normal state of affairs, we expect teachers to teach mathematics in school and to continue to engage students at their homes with games, with activities that they can then bring back to school and discuss what they did at home. In many cases, they will learn more at home than they did in school. So, what they did in school is terribly important because it's seeding the knowledge, setting the stage, but much of the learning will happen outside school. Or maybe in school, but not necessarily in the classroom. Maybe it will happen in the lab or in some intervention session and so on. So back in 2019, everything was, school-centered, teacher-centric, frontal teaching, using school devices, school PCs. Parents were, outside the process, and everything was focused on teaching. I think when you look at online learning using mobile devices in 2020, You can learn anywhere. Everything is focused on the student. Learning must be constructive. It must be hands-on. It's based on the notion of bring your own device, whether it's a laptop or cell phone, whatever it is. So in Matific, every student gets a username, and he or she can log in into Matific, and all your profile, everything that you did so far moves from one device to another through the cloud. So it's very comfortable. We encourage parents to get involved. And we found out that parents love Matific because then they can play with their children in games that they can relate to. And in some cases that they can learn mathematics together with their children. So everything is viewed as in a very positive way. And instead of teach, 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 we try to engage, engage, engage. So once again, how do you do it? Well, you do it by providing a complete top quality curriculum. In our case, it's mathematics curriculum that covers everything from preschool to 6th grade to the end of elementary school. You use all sorts of hybrid teaching models so that some of the teaching happens through Zoom, like I do now, and frontal teaching, and then you send the students to play games on their own, and then they come back and compare what they did with other children, and you can discuss it in the class session. So this is what I call hybrid teaching. Or in Israel, we also have something we call capsules. Capsules means that you can bring in a small number of children to school and teach a group of 10 students each time instead of 30 or 40. That's another example of hybrid teaching. Microcasting, but when I say microcasting, I mean, in a regular classroom, it's broadcast. The teacher teaches something and he teaches the same thing to everyone. But once you go into online learning and mobile devices, every student can get a different treatment based on his or her revealed competence. That's a great advantage of online teaching. I think the most important objective is to build intrinsic motivation. You want children to learn, not because you force them to learn, but because they want to learn. And the only way to do it is to engage and challenge and make learning something which is more of an adventure than a chore, which is unfortunately still the case in many schools. All right, so that's basically my my 2 pennies, and I'm open to questions, but I must tell you I'm a little bit deaf, and I have some hearing problems, and I'm not sure that I will pick up your questions very well. So in some cases, I will have to ask to repeat them, or maybe even write me a chat, and then I will figure out the question.
So may I stop sharing the screen now? Okay. I'll do that. Okay.
Yes.
So yeah, we're back to the, thank you firstly, Professor Shimon. I think what it loads out to us is that, see, everything at the end of the day, it's basic to understand, but then to make it more, if I may say, the right word should be participatory. At the end of the day, if he or she will do it by themselves, I'm a father to 2 young daughters, and having said this, the moment they do it by themselves, they are far more enabled learner, if I may say, educated, right? So I'll now quickly take up the first question, because I can see a show of hands, which is Swati. Swati, you can unmute yourself and then ask the question.
Hello, sir.
Yeah. Swati.
Sir, I would like to know how to teach the students, kindergarten students, to teach subtraction, because they find subtraction to be difficult. Addition
Right.
they can do, but how to do subtraction with the help of any kind of math manipulatives. So
Right.
how can we teach the child?
Okay, games. So here's an example of a game that teaches subtraction.
Yeah.
And actually it's a game that children love. We show a plate that has a number of cherries on it. Cherries. And make it easy to count the cherries because the cherries come in pairs. So you have, let's say, 5 pairs of 2 cherries. And we ask the children, how many cherries do you see? And the child says 10. Then a monster comes into the scene, and the monster is very hungry, and the monster goes like, "Rah!" And the monster eats some of the cherries, and there's a scene of chaos, and then the monster disappears, and there are 3 cherries remaining on the plate. And we ask the child, how many cherries do you see now? And the child says 3. And we show the child a little picture that shows the number of cherries before the monster came in. And then we ask, well, how many cherries did the monster eat? That's subtraction. Okay? That's one example of subtraction. So we have something like 20 games like this that teach subtraction using many different metaphors. And you see, one problem in mathematics, one challenge, I shouldn't say problem, a challenge is that each, by the way, let me say something which I think is obvious, but it has to be said. What children learn in elementary school is addition, subtraction, multiplication, division. That's it. They also learn geometry and so on. And we use this knowledge to drive in lots of other things like, quantitative reasoning and, trying to prove lots of things and so on in an informal way. But these are the 4 fundamental operations that they study. And so every one of them is supported by many games in Matific. And one reason that we do it is because, when you ask me, what is subtraction? There are at least 4 different ways to explain subtraction, right? There are different scenarios in which subtraction comes into play, mathematical scenarios, and so you need different settings, different games, different treatments to drive the concept home.
Next question.
Thank you, sir.
Yeah. You have a follow-up question, Swati? Yeah. I'll take up the next question. I personally believe we had this for 1 hour exactly. We are 11 minutes ahead of our schedule, but nevertheless, if there are other questions, we'll take up. Otherwise, dear leaders, the current association of IPN with Matific is that everyone who is part of this session, who's attending this session, has a 2-month plan available, or the resources which are available with Matific will be free of cost available to all of you largely. So we'll send you a detailed email after this session. The team will send you an email, and if you're interested, you can enroll for that largely. You have to sign an expression of interest, and then the team of Matific will reach out to you. Okay, so if there is any other question, we'll quickly take up. Otherwise, I'll have to say a big thank you to Professor Shimon, and then we will possibly look forward to another more session with him in detail. Yeah, any other question? We can have a quick show of hand. As I said, if you have either you can do a thumbs up. Okay, Devasmi. You can unmute yourself, Devasi. Yeah. You can unmute yourself and ask the question, and then I go to IHS Manju. Yeah.
Okay. My question is, I am from National Public School, Gulbarga. This particular system using Matific, can it be integrated along with Google Classroom?
Yeah, I know that we work with Google Classroom, but I don't have the details. But I know that we do work with Google Classroom.
Okay. Thank you.
Details from the team largely, Devashi. Yeah. Devashi, right? Devashi, is that the right?
Devasi.
Devasi.
Manju, over to you.
Thank you.
You can unmute yourself.
A very happy evening to all. My question to Mr. Shimon is, although we are, embracing digital learning, we are into learning revolution. And I have put a question across that how would we address the concern that mobile learning creates a lot of distraction or misuse the device for different purposes? Followed by that is, don't you think that multitasking hurts recall of course of material?
It's a big problem. Definitely, it's a big challenge that we have now. That this mobile device can take you to infinite number of places in addition to learning what you were supposed to learn. And I think that the only way to deal with it is once again to engage, to make the activities sufficiently fun that students will have, as I said, intrinsic motivation to learn. Otherwise, they will quickly go elsewhere.
Yeah,
I agree with you completely. I must say though, there are companies now that develop new operating systems for mobile devices that will be simply will provide a restricted environment in which the child can do only so many things, and you can use all sorts of policies. For example, you can say, I want students to do mathematics 5 hours a week.
Mm-hmm.
I don't care when you do it, but you will not be able to do anything else until you finish your quota of 5 hours. And so there are companies that work on this. I'm sitting on the scientific board of one of them,
Mm-hmm.
and I suspect that the problem will be solved at some point. But I think that a nicer way to solve it is to simply create great teaching materials.
Okay, thanks a lot. And somewhere, do you think that parents should also partner in this learning revolution?
The question was about parents?
No. It actually, it is focused for all the stakeholders. I'm saying so, if school takes the responsibility, do you think that parents should also partner in developing this learning revolution through mobile learning?
Absolutely.
Mm-hmm.
I think that parents should be extremely important players in this new environment, and we have to think, hard how to involve them.
Okay, and my last question: does Matific provide these gamification of the content, to be specific, as you have told about mathematics, so that we have certain things to orient parents also with, to help them adapt, that early education can start through mobile learning for these young toddlers?
Yes, yes. In fact, if once you sign up to Matific,
Mm-hmm.
If you work from home, you can, the teacher decides if they want to restrict access to only according to age or classroom and so on. The teacher can decide to open it up,
Okay.
I usually say, my advice, many parents ask me, how early can we start to use Matific? How early should we start teaching mathematics? And my answer is that the moment the child or the parent mention the number, then you can start teaching mathematics.
Oh, very,
so
very
for example, if the parent says, let's keep half of the cake for tomorrow, that's mathematics.
Relating to the real world, correct?
Yes.
Correct.
Amil Selvi, your question and this.
Yes, sir.
Please go ahead.
Good evening, one and all.
Good evening.
Am I audible?
You're loud and clear.
Yes.
Yeah. Thank you, sir, for the session. Wonderful session. Though I am handling IGIB for higher classes, this was a great session to attend to. And thanks for my HOS ma'am who has given us this opportunity. You have clearly explained this last example which you told us just before the other ma'am questioned us. Half of the cake being left out. So it's basically connected to the real world situations.
Yes.
So that's something very surprising and what we actually do in real classes. I just wanted to ask you, sir, why students get all this what we are talking about is all gaming and all grade 1 to 5. I am actually worried about the lower secondary section. When we start introducing algebra, people are afraid of math. Either they are afraid of math subject or the teacher who introduces them. Can this gaming through Matific enhance algebra concepts so that once they come to lower secondary like 6, 7, 8, they will be little more interested, and that's how we can catch up to the higher level of education. As you saw yesterday's NEP policy, 1 to 5 is going to be preschool, and they have all branched out like 5 plus 3 plus 3 plus 4 grades. The basic is to be framed, nurtured well, so that the students face it when they go to higher studies at easier payment. So, what's your suggestion? I really, we always are looking forward for this Matific email session so that up kindergarten from 1 to 6 can take up immediately. But from your end, I just wanted you to add on how to sort out this fear of algebra, specifically when they land up to 6 to 8 session.
Yeah. Guarva, can you possibly repeat the last question for me? Just the last sentence?
So the lady said that how can we mitigate the fear when it comes to grades 7th and 8th with respect to higher mathematics like algebra? Then the students have a lot of fear around it. How can we mitigate that fear? Yeah.
Well, you know, first of all, as a matter of focus, let's call it, we decided that in Matific, at least up until now, we focus only on elementary school.
Okay.
So we cover the whole curriculum from kindergarten, preschool to 6th grade. Now, the reason we did it was because, not because this mathematics is easier or harder and so on. We could also decide to focus on high schools, but we decided to focus on elementary school because we think that if you build a solid foundation in elementary school, when the students will get to algebra in 7th and 8th grade, they will be ready. They will be confident. They will feel comfortable with mathematics. And obviously, we also have to support greater classes, and we will. You know, we will develop teaching materials also for more advanced classes. But the reason we decided to focus on elementary school is to build a foundation. And I strongly believe that students will have a much easier time in middle school after they play with Matific in elementary school.
Hoping a great answer from your end, sir. Thank you. Hoping the same from the student side too. Thank you, sir.
Okay, thank you.
Okay. Well, with which I think we're completely out of time, Shimon. Thank you very much, everyone who has joined in. As I mentioned that there are more sessions we have planned for it largely, but having said this for today, I think we are done with our time bit. Any other question at all, so that I don't want to leave you guys out with a question yet, but I don't think there's any other question. So thank you. Thank you, Dr. Shimon. I look forward to see you sometime soon, but thank you very much for your time on behalf of everyone here at IPN India. Take care.
Thank you. Bye-bye.
Bye-bye. And take care, everybody. Have a great evening ahead. Yeah.
Thank you. Thank you, sir.
Bye-bye.